I'm going to talk about why you have to be concerned with allergens. So I'm going to lay down the law here in some areas. I'm with a company called Neogen Corporation. We've got a couple of folks from Neogen here. And we are in the business of food safety. So we are the sponsors of all 4 of the safety and compliance track sessions that are occurring today. And allergens is one area, obviously, that many people know us for, but we have food safety diagnostic kits for a lot of different concerns. So today what I'm going to talk about is what are food allergens, the health risks associated with them, the legislative history, how to develop a food allergen control plan, talk about validating and verifying your allergen control plan, and then where rapid test kits fit into the plan as well. So I'll talk about a little bit about definitions, what is a food allergen, and Jenna kind of touched on some of this, so I'll go through it relatively quickly. But what's unique about an allergen, as opposed to other reactions that you can have from a food, is that it's an allergic reaction. It causes your immune system to react. Allergens are naturally occurring proteins, and then the issue is that we can't heat or process them out of our food. They are resistant to extremes in pH as well. Quite often, they are the major protein in our food, and sometimes our food can have one or many allergens as a component. And then the other thing that's obviously important for us to remember is that there's no cure for allergens at this time. So the only way that consumers of your products can deal with the allergen issue is to avoid them. And so as Jenna said, there's all kinds of statistics she put up there. And the one that struck me is 1 in 13 kids. Well, that's significant, but you got to remember, those kids have families. And so if your child has an allergen, the whole family doesn't buy the product with that allergen. So, and then in the classroom, I mean, we all have instances we can relate to where if some child in the classroom has a peanut allergen, I mean, the whole school goes peanut free. And so it's becoming an issue, and again, some good reasons why it's a good business decision to be concerned and be dealing with allergens, but again, there are some other reasons why we need to be aware of this. So with respect to the health risks, again, what's unique here about an allergenic reaction is it's your immune system reacting here. And it obviously varies a great deal depending on the individual and the allergy. But these are some of the symptoms that most people could go through: hives, tingling in the mouth, swelling in the tongue or throat, difficulty breathing, abdominal cramps, vomiting, diarrhea, eczema, rash, coughing or wheezing, loss of consciousness or dizziness. And then the most severe reaction is typically referred to as anaphylaxis, and this is a life-threatening reaction. It typically involves the whole body, and the reaction can result in respiratory distress, shock, and even death. So as Jenna mentioned, these are the big 8, as they're called. Allergens in the U.S., peanuts, soy milk, eggs, fish, shellfish, tree nuts, and wheat. But clearly, that's an issue for us in the U.S., but in other parts of the world, they have a different set or a different perspective on allergens. So in Canada, for instance, they've got sulfites specifically mentioned, and mustard as well. So those of you who are in this country producing food for other countries, obviously you need to be concerned with their regulations and their requirements. And as Jenna mentioned, when we talk about allergens, we very often focus on peanuts. But maybe we're dealing with peanut oil or some other kind of edible oil, hydrolyzed proteins, lecithin, lactose, starch, gelatin, lysozyme, lactoferrin, soy sauce, Worcestershire sauce, natural colors, natural flavors. All these things could contain some element of an allergenic protein. And very often in the conversation about allergens, we talk about gluten. And it's important we understand gluten is not an allergen. It does not result in an allergenic reaction. What it is characterized as an intolerance or a sensitivity. And the symptoms are typically diarrhea, bloating, abdominal pain, weight gain, weight loss, and constipation. And as we all know in the US, what we're seeing more and more in the last few years is it associated with a healthier lifestyle. It's really become something that we're putting on our labels as a marketing claim. And there is obviously a severe reaction that can occur from a gluten ingestion, and it's called celiac disease. Celiac disease can be transmitted genetically, and it actually causes damage to the small intestine. And very often, most people never really know they have celiac disease throughout their life. Symptoms of celiac disease include anemia, softening of bones or bone density, headaches, fatigue, joint pain, acid reflux or heartburn, or nervous system injury. Okay, so let's talk about the requirements here in the US that have come about in the last 20 years or so that require us to be concerned about allergens. So the first of those occurred in 2004. It was the Food Allergen Labeling Consumer Protection Act. We often call it FALCPA, issued by the FDA. And here's where we got the definition of the Big Eight. So this legislation actually told us which allergens we need to be concerned with. And the only exemptions that were noted are highly refined oils. And the FDA stated at that point they would use enforcement discretion on soy lecithin. It does not address advisory or precautionary label. It doesn't really say how we should be labeling may contain, for instance. It does not set thresholds for us. It does not really cover raw materials, or at least doesn't specifically mention how we handle things like commingled grains. And it does mention, though, that the failure to declare any of these Big Eight allergens will result in a Class 1 recall. And a recall will trigger an entry into the Reportable Foods Registry. So in November of 2015, those organizations that are governed by the USDA FS, which is mostly food, meat and poultry type production, got their own guidance. And here the USDA FS focused on 3 areas to focus on. And the first was to identify through a meticulous comprehensive hazard analysis throughout your facility, prevent and control the presence of allergens through equipment sanitation and processing, make sure our cleaning is going to prevent cross-contact, and then the separation and segregation of ingredients within our facility and processing equipment and utensils. And the third requirement here is that we declare through our packaging, labels, things like that, when we have allergenic ingredients. So what you're going to see, interestingly enough, is that a lot of those things were incorporated into the FSMA requirements. So I think everybody is aware now, it's been talked about for a number of years, that there is this thing called FSMA, right? I mean, everybody is, I don't have to explain what that is. Okay. It has been implemented in a few different phases. And for this discussion, we're really going to deal with the allergenic component of FSMA. But be aware that as part of FSMA, there is a requirement to have a food safety handling system, and that it goes about the process of identifying hazards. And it places 3 categories of hazards that we have to go through and identify. The first is biological. The second is chemical, and that's where allergens fit. And the third is physical. And within the legislation, allergens are specifically mentioned as a hazard we have to control. And with every of these identified hazards, we have to have a preventative control in place to ensure that they're minimized or eliminated. And specifically, we have to have an allergen control plan. And within that plan, we have to have a way of monitoring that tells us that our preventive controls are consistently performed. And we have to have a method of verification so that we can say that, yes, the preventive controls are working. And that's where things like product or environmental testing fit in. Okay, so the question was, is an allergen control program specifically mentioned as requirement through FSMA? My interpretation is that it is, and that we have a preventive control for our allergen. Is that your question? Yes. My understanding is that it is. If you know something different, then by all means let me know. But my understanding is that you have to specifically have your allergen control plan as part of your preventive control. All right, and I mentioned these are requirements obviously in the US, but very often we're producing food that's going to be sold elsewhere in the world. And the European Union, for instance, has a different governing body called the European Food Information Council. And there they've labeled, or they've identified 14 different allergens and require mandatory labelings for those. They do allow precautionary labels, not in the ingredients themselves, but that there may have been cross-contamination, as an example. And there you could say may contain, and within the EU, the European Food Information Council is actually trying to establish some thresholds of what it means to have an allergen at a certain level where it's a risk. In the Asian part of the world, there is ASEAN. I was in the Philippines about 4 or 5 months ago, and I talked to a group from that area of the world. And there is an effort by the ASEAN Food Safety Network to develop their own standards and to revise what is or was in effect at that point. And from what I understood, what it's going to do basically is adopt a codex standard for labeling. So once we've identified the need to have an allergen control program, sitting down and actually composing one is obviously an undertaking. So we want to make sure that we're looking at the right areas for doing that. So what we're trying to do with this is to prevent cross-contact. We want to make sure that we're ensuring our label accuracy. We want to ensure accurate and adequate documentation throughout our process. And it's important that our plan identifies the key members of our group that are going to have to deal with the allergen control plan. And then the ultimate objective is to create, obviously, safe food for our consumers and avoid regulatory issues. So there's a number of different components within an allergen control plan. There is a risk assessment. We need to look at ingredients and raw materials. Our scheduling is important. Order operations and processing, process controls, maintenance, labeling and packaging, sanitation, changeover, cleaning. We need to have a consumer complaint system. Training is important as well, and then validation. I'll go through each one of these in the rest of my presentation. And you looking at a handbook here on the right. I should tell you that on your way out, please feel free to pick up this handbook, and there's several others that have to do with allergen control and food safety in general. So they're back on the table, and by all means grab one on your way out. All right, so let's talk about an allergen risk assessment. So when we go through and decide that we're going to have this allergen control program, we've got to obviously identify all of the ingredients that we have in our facility that have allergenic content. We need to create a list of the ingredients for products that come into our facility. So when we receive product, it's important, obviously, that we get what we're expecting that we get. And I've heard of some companies that go so far as to actually copying a label that comes in from a supplier and putting that on an acetate sheet. And when they get new product in, they actually take that and match it up, make sure it is exactly what it looked like last time it came in. So you have to go to that kind of lengths to make sure that you're getting what you expect to get. It's a good idea also that you walk through your facility with a schematic and say, all right, this is where product flows through our facility. And note areas that could be a concern if a spill or something happens. And then we need to obviously have lot tracking codes to track the product through our production, storage, and shipping. And it's important, obviously, that as a part of this program, we look at our ingredients or raw materials. And what that means is that now, not only do we have to be concerned with what's happening in our facility, we got to go back a step or two with what's happening in our suppliers' facilities. We really have to think in terms of, all right, what does their allergen control plan look like? And are they labeling and providing what they're supposed to be providing to us? We need to make sure we get certificates of analysis that are current and reviewed and contain full disclosure of all ingredients used. And it's important, obviously, that we have a good relationship with these suppliers so that if they change their formulation, they tell us, and preferably before they actually make that change, so we can make the changes and adjust to whatever needs we have at our end. So we need to make sure that ingredients coming in are clearly labeled with allergens. We need to give them a specific lot number and track through our system. It's a really good idea, if we can, to have a designated and segregated area in our facility that is just for allergens. Where we can't do that, if we have to stack, for instance, ingredients, it's a good idea to store the allergen on the bottom. And it's also a good idea to have color coding for totes, bins, things like that, and pallets, labels. Again, the idea is we got to make sure that we know where all these allergens are at all times. Okay, equipment and engineering. I think what's interesting is that when you go through this process, you look at things a little differently. And one of the things you look at is the equipment that's producing your product. You're looking for things like dead legs, dead spots that can be areas where food aggregates during production and after cleaning. You need to look at your equipment annually and see about those dead spots and rough surfaces and try to avoid those if we can. And when you look at equipment now, I think you look at them a little bit differently. You look at equipment in terms of things like this. Can that be cleaned? You know, it's been interesting in my 15 years here in the food safety industry how people look at food production equipment differently now. It used to be about production. It used to be about volume. Now it's about things like this. Can I clean that piece of equipment? You really have to make that assessment. And we're always trying to make sure that we avoid a situation where product goes across other products. You know, you might have conveyor belts that are at a certain height in your facility, and it goes right across another conveyor belt that, you know, there's an allergen up here, and there shouldn't be an allergen down there. So you have to look at things like that. And then also air handling systems can spread, obviously, if we've got dust and particulates. We have to be aware of that impact. So in terms of our operations and processing, there are some things that we can do to lessen the risk of allergenic contamination. One of those things is to introduce allergenic components as late in the production process as possible. Whenever possible, we want to try to avoid manufacturing an allergenic product before we manufacture one that shouldn't have that allergen in it. It's a good idea to schedule long production runs of allergenic-containing products. It's a good idea to have an allergen matrix for changeover. So when we have production of an allergenic-containing ingredient, this is what we do in our changeover and sanitation scheduling practices. And if we use rework, it's very important to make sure we use the exact to exact philosophy. Other things we can do is we want to make sure that single-service items are not reused. When we're sampling things in process, we want to make sure that those things we use to sample aren't contaminating the next thing we take a sample of. We want to double-check our formula when we scale up. And ideally, we'd have physical barriers that physically separate areas where allergenic product is flowing so it doesn't come across and come into contact with non-allergenic product. Labeling and packaging is a very important component in our program. We need to have a label SOP to make sure that all necessary steps are taken for accuracy. All product changes need to properly be documented and synchronized between labeling and manufacturing. Minor ingredients, processing aids contain allergenic protein. We need to make sure that they're properly reflected on our label. And precautionary labeling, if you were going to use this, we really want to have a good reason to say may contain. A lot of people look at may contain as being something that I just don't want to go to the trouble to find out that there is this allergen here, so I'm going to put this label that says may contain on there. And I think that's bad practice. It's bad practice for a few reasons. Again, we made the case for the economics. You know, if you put may contain on your label, you've automatically told a certain group of people don't buy your product. So clearly there's an economic reason for getting it right. I think the reason why you use a may contain label is if you get to a point in your process, you've gone through all this, and you just can't be sure that your allergen or your product is not allergen-free, then okay, then you would want to use that. But again, I wouldn't ever want to recommend doing this until we've made that determination. We just cannot control it for whatever reason. We have to put that label on. I think there you've got a valid reason for using it. And obviously, it's important we get the label right, because if you look at the recalls, and I think Jenna said that the number one reason now for product recalls is allergen. It may contain allergens. And what this graph is showing us is that 70% of those times, it's really about labeling. And when you think about reasons that you could control, certainly these are within your scope of control. All right, and then the final component of the sanitation, or rather of the allergen control program, is our sanitation program. Because here we're talking about making sure that the production run today doesn't contaminate the production run tomorrow. So we need to identify all the equipment, including conveyors, food contact services, et cetera, that require cleaning after an allergen run. And we need to make sure that we include things like splash zones, indirect product contact surfaces, utensils, employees, sampling equipment in our SSOP. On pre-inspections, it's important that you specify your allergen check points. We need to focus on hard-to-clean areas, including valves, dead spots, pumps, corners, welds, and angles. Ideally, we want to try not have those in our facility, but if we've got them, we've got to make sure that we're monitoring them especially. And we want to consider using color-coded cleaning utensils. So if you're going to clean something that has allergenic content and you use that same thing to clean the next piece of equipment, there's clearly potential there for cross-contamination. And then we need to have an accident plan. So what happens if the forklift goes out, picks up a bin of peanut and drives it over here and it falls over? I mean, what's the plan there? We actually have to look at this as something that we have a reaction to. We have a formalized plan that says if that happens, this is what we do. And then once we establish sanitation as being important in our allergen control program, we need to validate that our sanitation is actually removing the allergen from the surfaces. So we need to have a validation step. And I'll also point out to you that one of the handbooks that's in the back there is this one right here on the right. That's best practices for food allergen validation verification. Goes through it in a lot more detail, of course, than I will. But actually walks through the steps and how to validate your cleaning to make sure that the allergen is removed through that process. So the purpose of the validation is to confirm that our cleaning process is effective, sufficient, implemented, and will produce consistent results. So we got to validate. We got to say, all right, this is what we're doing with our SSOP. Does it actually remove allergens? So the current standards suggest that we need to validate our cleaning for all of the big 8 allergens. But in practice, what people often do is to validate it on the one they think is most difficult to clean. If you've got a sticky peanut butter, for instance, obviously you could make the case that if we remove the peanut allergen through our cleaning process, that ought to remove all of our allergens. So that's the theory. So you would look at the most difficult to clean, or potentially the one allergen that you've got in your product that is the highest in concentration. So there's a couple different approaches you can take where we don't necessarily have to validate our cleaning on each of these different big 8 allergens. So if the allergens are present in particulate form, chunks, then we have to think very seriously about how we sample for that. Because very often they're not evenly distributed. They're very randomly distributed, and we have to make sure that we figure out a way that we're accounting for that. But throughout all this, the very first step when we do a cleaning validation is we look out with our eyes and see, does it look clean? You know, because I'm going to talk about the ways that you validate your cleaning, but the first way is you look with your eyes. Is it clean? That's the first standard. Is it visually clean? If you see residue on a surface, you don't need to test that. I mean, there's clearly your sanitation program did not remove that soil. Finished product by itself is not sufficient to validate your cleaning because of the dilution that can occur through the production process. And then for dry products, very often people adopt a 3-product flush approach to get rid of the allergen within their system. And then, as I mentioned, we've got a handbook back there that really goes through this in detail, but I'll just kind of highlight the steps here. So the first step, when we go out and we validate that our cleaning is removing the allergen, is to identify a corrective action. What happens if we do find an allergen? So what are we doing if we find an allergen within our facility after cleaning? So we have to have some kind of a plan of action. The second step is to make sure that whatever method we're using, whatever test system we're using, will actually pick up the allergen that you've got in your product. And the way you do that, you just take your product and you test it on the test. And if you don't get a positive, then clearly you're not going to get a positive on your equipment. We need to identify all the equipment and surfaces that come into contact with allergens. And we need to swab multiple representative samples for each of these pieces of equipment. We want to record where there's a visual allergen present. And if we do that, if we can see a correlation between visually clean and when we test and it's clean, we can make the case that visually clean is part of our standard. But what we want to do is we want to test at least to a point where the swabs are negative, or really the better term is below the level of quantitation, BLQ. And then you would proceed to first off push through product testing. And regardless, you want to hold product. Best practice would be to hold product pending a negative or below level of quantitation results. So once we've got this validated cleaning system, it's important we keep in mind that things can change. And these things could impact our validation assumptions. We assumed certain things when we made this validation, but if those assumptions change, we need to revalidate. One of those things that we assumed is we had a certain product. If that product or a different product is added to the production line, we need to revalidate. If we got a change in our process or equipment, it implies a need to revalidate. If we change our product formulation, change our cleaning, SSOPs, including personnel, or at the very least on a predetermined basis every 2 years. And if we've identified changeover as a critical control point, it needs to be validated. All right, so a lot of folks are using test kits to monitor their allergen control programs. And this is where we're seeing that usage help them out. One is with sanitation validation, to detect manufacturing issues, to verify supplier ingredients, to identify that there are allergens in their own products, and then on routine finished product testing. And then I want to talk about the other way that people are using to validate their sanitation, which is through ATP testing. So ATP testing is the most common method that food production companies use to validate their cleaning. And it's a terrific product, does a terrific job, but it's not going to tell you there's no allergen on your surfaces. And the reason it isn't because ATP is not protein. ATP is adenosine triphosphate. It's a chemical produced in every living cell. Protein's something else. And so when you have a system that's measuring ATP, it's not measuring the allergenic protein. So it's important we get that distinction. Now, maybe we can establish a correlation. Very often you would think there should be, but we can't bet on that. It's too important of an issue. So the best practice is to use an antibody-specific test to confirm. ATP is a good surrogate, and we can, like I say, sometimes establish a correlation, but we should supplement our ATP testing with allergen tests when possible. All right, so I'll finish with a couple of slides to just talk about the way that we can do this allergen testing. There's a couple of different platforms that most folks are using to do their allergen testing. The first is called lateral flow device. If you've ever seen a pregnancy test, same concept. It's a stick, basically. You can see each one of those blue, brown, et cetera, devices is a little plastic device about like this. We got a bunch of them on the table back there, arrayed like a rainbow, like it's there. But the important thing is each one of these is for one allergen. So you see you've got an almond, you got a gluten, you got a hazelnut, you got a sesame. And basically, these will act as a screen. So they are going to form a line, visual line, at a certain percentage or a certain ppm, typically, of that allergen. The good news is that this kind of test is very easy to do. There's no equipment required, and it's ideal for testing things like the environment, CIP rinses. It works very well in a swab type of application. And you can get an answer in 10 minutes. So it's a very convenient, on-the-floor type of test. And this is, I brought this up, I didn't know if people would care this much to know the technology, but I think it's fascinating. So I mentioned that, again, you've got a plastic container, and if you take that thing apart, this is what you would see. So you've got this sample pad. So when you put a droplet of liquid on that sample pad, and it basically flows across another pad that has the reagent. And then it's got another pad there where the lines will actually form, because these antibodies that we use are adhering to the allergen. And those, in fact, are attached to a little ball, basically. And that ball stops in these different target lines if the allergen is present. So that's how you see a line that tells you that the allergen is present in a certain concentration. The other type of test that people use to detect the presence of allergens is called a microwell test. And a microwell is, you see it down here at the bottom, these little wells, they're about like that big, look like a little test tube. But what's different between a lateral flow type test and a microwell test is that you can see in that picture there's a lot more equipment involved. This is something that is better done with a lab of some type. But the good news with this type of test is that we get actually a number. So we can say there is this level of concentration of peanut on our equipment, in our product, whatever. This is a better test, or more often used on product. But certainly when you talk about a validation step, if you're validating your cleaning, one of the good uses of this test is to find out, all right, well, this time when we did our cleaning, we got to a 20 ppm level. That's not good enough. So let's try something different. And then this time we got it down to 10 ppm. So you're seeing some improvement. So you could potentially use this type of test to gauge improvements that you're making in your sanitation. More often, though, it's used for finished products, ingredients, in-process, and environmental tests. And if you send your product or you send swabs out to a commercial testing laboratory, this is probably what they're using.
A couple minutes for question and answer. So you can just raise your hand and, yeah.
And I'm just wondering about the test that quantifies things versus just a yes or no test.
Mm-hmm.
It seems like for most allergens, it's very important that there is none present versus, just it seems nicer to know that, like quantifying it is nice to know how much, but are there allergens that are more, you want to know the amount that's present and there's a small amount that is allowable, or?
It's a really good question. It's a really good question. And the reason it's a good question is because it depends on who's looking at the result. And if the person looking at the result is your auditor and they see a number, what are they going to think?
Yes.
You got an allergen problem, right? So you got to think about that. Whereas with the lateral flow device, you'd have a yes/no screen at 5 ppm or whatever it is. So the microwells tend to be a little more sensitive. So I'll just tell you that. So what you do with that information, of course, is up to you and your auditor. But certainly there are auditors who would look at a 4 ppm result and say, well, you got an allergen. Well, you've got it below 5 ppm, and that's generally recognized as kind of an action level, even though it's not specifically stated. So again, you got to at least understand what you're looking at to make that determination, I think. Does that help?
Yeah, like gluten
okay.
is something that isn't it like 9 parts per million?
Yeah, so gluten, yeah, right. There is a number, and I can't remember what that number is that has been established to say it's gluten-free. So yeah, there would be very helpful. Okay, other questions? Yes? So what you're seeing back there is our Neogen's products. We don't have a coconut test right now. We're in the process of developing one. I've been saying that for a while, so I don't know when we'll have that, but there are other coconut tests on the market. And your question actually brings up another question that I get asked quite a bit. And so what happens if you've got an allergen in your product and there's no test for it? Because that is the case with some areas. And what I'll tell you is that there, you got to pick a surrogate, or you got to do something. You got to make an argument to whoever is, auditing you, or you're having to explain this to. There's got to be some logic behind it. Okay, we don't have a test kit for that particular allergen, but we do have this allergen also, and we can test to see if that one's there, and we can make the logic that if our cleaning removes that allergen, then it should remove all the allergens. So there are things like that come into consideration. So our tree nut test kit does not detect coconut, yes. So we have a multi-tree nut test kit at Neogen, and it detects 6 different allergens, and tree nuts and coconut is not one of them. So the question is, in a dry production, dry product environment, it's a challenge, no question. So there, you just do what you can do, and you're dealing with particulates very often. And if you can't, if a product doesn't work for you, then at least you can tell your auditor or whomever is asking a question, we tried that, doesn't work. If an auditor comes in and asks you a question that you don't have an answer for, or don't have logic behind it, then you're in trouble. As long as you've got some logic behind the reason what you're doing that can be supported, I think you're okay. So, okay, other question? Yes.
That dry process, essentially 3 purges, 3 flushes. Is that with the actual product or something like salt, or can you expand?
I've heard of people doing both. I've heard of people using salt, and I can't speak to it from personal experience. Again, what I'm relating to you is what I know some of our customers are doing. And I don't know enough to tell you exactly what they are doing. I just know that some people are doing salt, some people are doing product. 3 times supposedly is the charm. And then I'll also relate to you that a lot of what was on the screens and what we all know at Neogen, we work with a group called FARP, F-A-R-R-P, Food Allergen Resource Program out of the University of Nebraska. And so a lot of what we know has come from them. And I think actually, I remember Steve Taylor actually was the guy who told me this. So. He's a guy who I trust and know he knows what he's talking about. So. It's a good question, and it became a lot more interesting the last year or so, didn't it? When we had, for instance, I'm sure a lot of you are aware that we had product recalls on flour because of the presence of peanut. And what we found out there was that they were both being shipped in the same kind of containers. In this case, it was rail cars. So there was this cross-contamination that occurred that we found, basically, or people found just because they thought to test and find out. And so until that time, that was probably been going on for many years, people just didn't know it. And I don't really know what prompted that initial test or that discovery. I don't know if someone had an allergic reaction. I guess I don't know. Greg, do you remember what prompted that? But regardless, again, if we have tools, we can use them and try to discover whether or not they're an issue. I think at the very least, that would be the ideal. So if you can run a test on your product, I would try.
Well, are the tests effective? Like I've seen, just looking at packages occasionally, I'll see a little grain of wheat among all the lentils. But would a test like you're talking about actually show any result if you just have a whole grain of them?
It could, absolutely, yeah, absolutely. Yeah, there's a certain concentration. I don't know, one grain in a package, I don't know what that would be, but there's a certain point where we would pick it up. So I would say, give it a try and see if it works. If it doesn't work, then at least you've given it a try. So
what's your recommendation on verification frequency if you can't do it?
anytime that you're putting together a plan, a food safety plan, allergen control plan, whatever, you got to take real-world considerations into the plan. I mean, we can't test every single inch along our conveyor belt. We got to use some logic. We got to say, all right, we got a budget. We got to stay within a budget, and we got to work with what we got. And so, if we can't be testing every production run, what we want to do is to validate that our cleaning should remove it, and so we test every 4th or 5th or 10th, whatever logic, whatever we can afford, I guess. And at the very least, we've got some logic, again, behind why we made this decision. That we've done our validation, and we know that our SSOP does remove, so we use a 1 in 10 verification, rather. So, I mean, there's lots of different things that go into this plan, one of which is our economics. And unfortunately, that's true of every food safety program I've ever seen. You know, I mean, why don't you test more? Well, because I got a budget and I can afford this many tests, and so that's what I got to live with. So the real world is that's what we got. So, yes.
I was just going to add to that, they're, like FDA, got into a recall situation. I've been probably I'm a food safety attorney, but they would go back to your last clean break. So that's a business decision of where do you want to set those clean breaks.
Yeah, that's good. That's good. And it also has to do with recalls, right? So if you produce a lot, and that there's any problem within that lot, the whole lot gets recalled, and that's basically what you're saying, right? Yes. Okay. Any other questions? Yes.
Yes, Case Webster, I'm a consultant as well. I work with a flavor company who runs a flavor that has peanut oil in it. It's highly refined oil, and they're still testing for it. But my concern is that they're never going to find it because it's a highly refined peanut oil. And I was curious what your procedures are from the standpoint of how sensitive your test is.
Yeah, and I'll tell you, that's not really a question of sensitivity. It's a question of the protein becoming denatured and potentially not reacting with the antibody. So I would say, try it, see if it works. We know sometimes it doesn't. It really does depend on the denatured protein. But then you can make the argument, well, if the protein's denatured, maybe it's not allergenic. So there's a lot that goes into that discussion. I would say, again, try and see if you can find it. If you can't find it, then at least you made the effort.
That's what I told them.
Good. Well, good. Yes.
You talked about allergens not being able, being resistant to heat and stuff. If
Yeah.
you do denature a protein, does it still have an allergenic response? Does that depend on the allergen?
So what I'll tell you is I don't know the answer to that question. I'm not a doctor. I don't know for sure. What I think I know is that it can. In other words, it changes the protein enough where your body does not have a reaction to it. But I'm going to guess that's not always the case with everybody.
Like what part of your
Yeah, I think that's probably right. But again, I don't know enough to answer your question for sure.